Alright, on today's episode of Python Papi, we're back inside our TensorFlow course. We're still doing our CovNets module. Let's have a look at what we went over today. Now, yesterday, if you recall, we started the process of talking about padding, and today we're going to pick up where we left off. So also note that one good thing when working with a library like TensorFlow is when we don't know the exact padding to use such that we have a particular output size, we could specify the pattern to be valid. Once we specify the pattern to be valid, TensorFlow automatically calculates the padding for us such that the output we want matches up. Up to this point, we've been supposing that our input image is two-dimensional with a height and a width. Now, what if we use the kinds of images we have in real life that are 3D images, where we have the red channel, the green channel, and the blue channel? And for those of you who don't know, that's going to be our RGB. So if we have an RGB image, we'll see how we can get the output. The way that this is done is quite straightforward. So what we do in this case is include the padding. What we do is multiply each element of our kernel or filter by its corresponding element in the input, starting in the top left-hand corner, including the padding, and then add all of the resulting elements up. Then we will slide our kernel or filter to the right. One second, let me move down some. And repeat the process. We will do this until we have done the entire width of the input grid. Once the width is complete, we will do the same process for the height. We will do this process for each RGB channel grid in our 3D channel. This will give us our output for the 3D image. Now let me move up a little bit so I can show you exactly what that may look like. So say this was our image, our 3D image here that we wanted to do. We would have three of these, one for red, one for green, one for blue. And what we would do is each one of these pixels would have an element or a number inside of it, and that will correspond to one of the numbers in our kernel size, which by default is 3. So each of our kernels will be 3. And then we multiply each one of those threes with the corresponding number inside of the element here inside of the input. So if we had a 3x3 filter here or kernel inside of this input, let's say this was 1, 2, 3. It will be 3 times 1 plus 3 times 2 plus 3 times 3, all the way down for the entire kernel or filter. Then we would move to the right and we would do the same thing again. It will be 3 times 2 plus 3 times 3 plus 3 times 4, all the way down. And once we did the entire width, we would start with the height. So that means we would go down one and then start the process again here. And we just go on and on and on. And we would do that for each channel, the red, the green, and the blue. And that would give us the output for our 3D image. Now we did take a lot more notes and we did go over a lot more stuff, but I want to go over it piece by piece so I can have an understanding of it piece by piece. If I try to jumble too much of it into one sitting, then of course I'm going to forget some things that I went over initially. So yeah, we're going to leave it there for now, but we will pick it up tomorrow. And of course I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.